A path-breaking design for AGI, Part 4, Intelligent Learning Machines. The simplest way to build a learning machine is to design the system such that as learning progresses only data changes, and not the code. Like in the Java virtual machine, the same program, JVM, would exhibit different behavior as the data or bytecode changes. This means designing the equivalent of a JVM and feeding it structured data from a subjective knowledge base like the one in previous video. Therefore, as the knowledge base improves through learning, the behavior will improve and grow more mature. However, the program flow control must be accomplished using the knowledge base's declarative semantics and conscious awareness. Enhanced semantics of subjective knowledge bases. The nodes and links in the knowledge base already have important associated semantics. These may be enhanced further as explained here. Subjectivity and imagination are limited by nothing, not even the laws of nature. We could travel at infinite speeds in our imagination. We can imagine impossible things, not just unreal things. Philosophy says such things subsist and subsist, rather than exist. However, while this solves the expressive power problem, not all entries would be of practical value, and some would even be wrong. Furthermore, for the JVM-like design to succeed, program control flow, resource and timing management should also be handled somehow. Universe of Discourse, UOD. The best way to separate the fiction, fantasy, and in fact various domains of knowledge is by confining each to its own universe of discourse, as suggested by philosophers. An UOD may be a combination of facts grounded in reality combined with hypotheticals, beliefs, hopes and wishes as well. Knowledge, information, and beliefs may be partially or wholly usable in other UODs, based on some rules. For example, scientific knowledge may only be partially applicable in a science fiction UOD. The separation into UODs simplifies both the representation and the process of training for the learning machine. Program flow and resource control. Storyboarding, mentioned in the video on consciousness, is invaluable in representing the execution path for the program. It provides the ability to represent complex information without the need for names and language, using subjective elements. The storyboard can in addition be used to specify the necessary resources, and the steps needed to acquire these. The same logic used to process conscious experiences for consistency can be applied here to validate the logic in the storyboard. The mechanism of control will be discussed in detail in the next video. It suffices here to state that the affect and perception control theories, ACT and PCT, will be used for that. Power behind clusters of perceptions. The knowledge to invoke specific functions to control each perception may be leveraged to operate on a cluster of perceptions. In most cases, there would be several options to choose from, to control each perception. On the other hand, there may be cases where no object or strategy would help. Then, additional learning is required. Clusters give additional structure to a subset of selected perceptions. This allows us to enhance the associated semantics. A cluster is a collection of related perceptions for a task or a problem. All these perceptions must be considered in any solution. Missing any will result in actions that will appear to lack common sense. Subproblems and nested clusters. The clusters can contain subclusters to produce complex structures. The subclusters may be used for control by another set of perceptions. A solution to a simple task or problem may involve the following steps. Use the UOD and knowledge base for the problem solution space. Select from the available objects and strategies. Use the EPA to emotions mapping for optimizing the choices. Build a storyboard using rules of the UOD to ensure that the selected objects and strategies are implementable. While implementing the solution, Use feedback in PCT to ensure that the storyboard constraints are being met. If not, revise the plan from the current stage. A cluster for learning. The solution to the task of learning itself can be captured in a cluster. To learn a new subject, these are the steps that must be followed. Build a new UOD, and fill it with solution objects and strategies. Create training exercises to experience important perceptions. Train to use objects to bridge undesirable counterfactual gaps. Load available clusters, and create more useful ones. There are many more suggestions in my book, Purpose, in the Learning to Learn chapter about enhancing the quality of perceptions. This set of 4 videos summarizes the high-level design proposed for an intelligent learning machine. Thank you for your interest.